Hello, everyone. This is Jim May, Marketing Manager at Index. I want to start out by thanking you for taking the time to join us today. This is our webinar focused on the parts that benefit most from being processed on a turn mill. We have with us here today Ed Weinberg, our Regional Sales Manager, and Mark Page, one of our Applications Engineers. A couple things before I turn it over to them. First, I know some people are still working from home or remotely and logging in through VPNs. We would advise if you're joining the webinar and on a VPN, you might want to quickly log out, hop off the VPN, log back in, just to ensure that some videos we're going to play run as smoothly as possible. Also, we're going to be doing a little Q&A at the very end that we've allocated some time for. So throughout the presentation, if you have any questions, please feel free to enter those in the questions box on your control panel. We'll hold those to the end and then go through, and Ed and Mark will respond to those before we sign off at the close. So without any further ado, I will turn things over to Ed and Mark.
Well, good morning or good afternoon, depending on where you're located. Thank you for joining us. We're just going to go through a little bit about turn mill machines and some of the parts and ways that you can profit from them. My name is Ed Weinberg. I'm a Regional Sales Manager here at Index Corporation. I have been with Index in total of about 10 years. I've been in the industry 33 years since I got out of the Navy. Worked as service engineer, and I've worked as an applications engineer also before getting into the sales side of the industry. So been around a few years. Mark?
Yes, my name's Mark Page. I'm an application engineer for Index. I've been there approximately 1 year so far. I have 41 years experience in industry. The last 20 or so of that has been as an application engineer for various builders up until now with Index. Okay, Ed, over to you.
For the purposes of this webinar and the discussion here, we're going to talk a little bit about, what defines a turn mill to begin with. Turn mills are really very specific machines. Typically, they will always have a dedicated milling spindle and one or more turrets. The milling spindle can be a number of different types of spindles. They could be gear-driven, they could be a trunnion style or a motorized milling spindle, but there's got to be one milling spindle on, at least one milling spindle on the machine. Also, another aspect of a turn mill would be the number of tools, and usually it's in the neighborhood of a minimum 50 tools in the machine. Some in the tool changer, some in the turrets, but minimum 50 tools. The benefits of turn mill. There's a whole slew of benefits, but we're going to focus primarily on about 5 of them, which I think are the most important ones. First of all, we're going to focus a little bit on work in progress and where you'll benefit from the turn mill of reducing work in progress. We're going to talk a little bit about the capability of the machine and the fact of being able to machine more complex geometries with a turn mill than you typically can with any other machine. We're going to talk a little bit about how much less labor you're going to be utilizing and where that labor can go within the shop. We're going to talk about accuracy and the tighter tolerances of being able to machine parts in a single operation with doing many of the features of the parts that typically would go to a different machine. And briefly touch off on the large tool capacities and where your benefits come from the larger tool capacities. So we'll start here with work in progress. Work in progress is the enemy of every company that machines parts. There's a cost to work in progress. Many places define it in different ways. Some don't define it at all in the pricing of their parts. But work in progress is something that, going with a turn mill type machine, you can eliminate this work in progress. What does that give you? Well, first of all, it's going to give you a simplified working schedule. You're not going to have to schedule multiple machines in order to go ahead and process the parts. You can be more responsive to your customers. Since we're streamlining operations into a single machine, You can respond to your customers with parts at a quicker delivery. Also, you're going to reduce the window between the expenses of machining the parts and the revenue for invoicing back to the customer. Bottom line, we all want to go ahead and get paid as quickly as possible. So by being able to machine parts quicker in a single operation and minimize the cost of work in progress, we can go ahead and invoice sooner. This is this aspect here of complex geometries. This is probably one of the large ones that most people will look at to begin with. Being able to machine more complex parts and features in a single machine gives companies that ability to be far more competitive in their bidding process. When you are doing multiple operations on multiple machines, your bidding typically is going to be a little bit higher, but your turnaround's quicker on one machine, and you can be a lot more competitive. What we're doing, how you're doing that is drilling and milling angled features. That opens up new doors to a lot of new work. Typically, if you're trying to do angled features in a standard turning machine with live tooling, that's going to be done with angled live tool holders. Very expensive, typically weak, not very strong, and so it's not very profitable or competitive to go ahead and utilize those, forcing you to go into a milling aspect. Utilizing a motorized milling spindle or a milling spindle in the machine allows for more productive machining because of the fact that it's going to be more horsepower, it's going to be more torque than what you would have in a live tooling situation in a standard turret machine. This gives you the ability to go ahead and machine more aggressively and be able to machine tougher materials. In many cases, you'll be able to use a simultaneous 5-axis milling in a turn mill machine. Most machines will come with 3+2, some 4+1, and some you'll be able to do full simultaneous 5-axis milling. This makes it much more efficient too, because that gives you the ability to go ahead and do this on a turn mill machine rather than a dedicated 5-axis machining center. Some turn mill machines are capable of machining gears and very accurate gears. Also, some have that ability to grind certain features in the operation. These are typically considered other equipment, dedicated equipment to do these features. This can save you money from having to invest into dedicated equipment and reduce some labor costs. Also, in many of the turn mill machines, you can machine larger parts that you typically would not be machining in a turning machine. By use of steady rest, by use of spindle transfers, things of this nature, you can machine much larger parts in the machine. Labor. Everybody knows that labor is hard to come by. Qualified people. Combining things into a single operation reduces the need to be hunting for more people. With this capacity in a turn mill, you're not going to have to try to recruit and train new operators. Everybody understands you train operators. Many times they'll jump ship and go elsewhere after you train them very well. So this can help reduce that need in order to hire new people. By doing operations in a single operation, the operator's time can also be utilized for other tasks within the shop. And also what's very important here too is moving of parts. And when you can start getting into the larger parts that you can put into a turn mill, loading and unloading these parts can be dangerous. By doing them in a single operation, you can reduce this part handling by at least 50% or more if you're doing two operations in a one. So as far as reducing potential accidents, that's something to think about also. Turn mills, typically, people are always trying to do everything in a single operation. That's really the benefit of where we're getting into this. And by doing so, you increase your accuracies. As everybody knows, each time you move a part between machines or fixtures, it adds setup time and it reduces that ability. to be able to hold demanding tolerances. And we all know our customers these days are demanding tighter tolerances than ever before. So by not having to move to a different machine, it's a lot easier to hold the tolerances that you're dealing with. Also, for most parts requiring milling on 6 sides, a turn mill is really the only way that you can go ahead and process that part and do a single operation. On a standard milling machine or a 5-axis machine, you can only mill 5 sides. Then you have to reposition the part, refixture it, and mill the 6th side. In turn mills, you're able to do the milling on all 6 sides in a single setup. Again, increasing your accuracy and your tolerances that you can hold. Flexibility. In the turn mill machines with larger tool magazines, this gives you the ability to turn around jobs quicker. With the larger tool capacities in the tool magazines, you can do changeovers sometimes with no setup or very minimal setup because of the tool capacity that you have in the machine already. Not changing bar stock or work holding, simply nothing but a potential of no setup time at all, just a new program and off you're running. Also, with the larger tool capacity and the tool changers, you can duplicate tools, redundant tooling. Redundant tooling is ideal for unmanned operation and unmanned production. With a lot of the tool monitoring systems out there, when a tool breaks or wears, it can automatically go and get to the next tool. So some of the benefits of these larger tool capacities is greater unmanned operation. Now I'll get involved here with some of the turn mill parts. Mark, do you want to take over here?
Yes, thank you, Ed. So basically, what makes a good part for a mill turn machine? So essentially, it's normally, a high content and milling operations, or a part that requires more tooling than you can fit into a conventional turret machine. Parts with angled holes or angled features are a very good fit. And also, as Ed mentioned earlier, 6-sided machine in the mill turn is really the only platform that can handle that. Okay, next slide, please, Ed. So basically, if the part's just turning, normally a conventional lathe is the right fit, but there can be some instances where, a turn part can require certain tool angle geometry, to reach difficult to machine areas where a mill turn still makes sense with the B-axis head. And also parts that are pure milling, 100% milling. It could be that you've got a turned operation and then a heat treat operation and then loaded to the mill turn machine, and it's pure milling operations. It still makes sense because it acts like a milling machine with an A-axis and a B-axis head. You can still manipulate the part, rotate the part, and reach all the features. So it still makes sense as a good milling platform. Next slide, please. So angled features. So, you get a lot of parts that have angled holes or angled ports where they require drilling, milling, thread milling possibly, chamfering. The mill turn machine makes a lot of sense in this regard because it can orientate the part, orientate the B-axis, and reach pretty well any angled feature on the part. Features that are difficult to reach on the main spindle can be transferred to the counter spindle, and the head can be reversed and reach those features also. Okay, next slide, please. Complex geometries. This is where the mill turn really comes into its own. 5-axis machining. All of our mill turns with the B-axis head have 5-axis capabilities. That means all axes can machine at the same time and simultaneously. For these kind of parts like blades, blisks, impellers, and sometimes just parts where you need to shorten the tool to get into difficult to reach areas, and on a conventional machine, the tool would be extremely long and cause vibration. That can be a good fit for 5-axis machining. And of course, again, the mill turn machine can 5-axis machine on the main spindle and also on the counter spindle. Next slide, please. So long cycle times. If a part's got long cycle times, typically it's because it's got a lot of milling or a lot of heavy turning or a lot of operations with a lot of tools. So again, this is always going to be a good fit for a mill turn machine. And the index liner machines, we have lower turrets with Y-axis. On some machines it's a single turret, on others it's 2 turrets with Y-axis. So this can enable us to cut down the cycle time, simultaneous machining on the counter spindle with a turret or B-axis, whilst machining on the main spindle. Okay, next slide, please. So turn and mill features together. So one of the huge advantages of working on a mill turn machine is that you can do the turning, and you have turn datums that are called out to the milling features, and you can withhold that accuracy because you're doing it all in one operation. So that makes a big difference. Also, one of the other things on the mill turn machine that's handy is that we can incorporate a probe, a touch probe on the machine, and measure while we're in process, and that probe can be put away in the magazine so it doesn't get contaminated with coolant and chips. Okay, next slide, please. So now we've got some real world examples. Okay, next slide. Okay, so the shaft here, basically there's not a whole lot of milling content on this part. It's primarily turning. There's a cross hole and a little bit of milling in the keyways. The big advantage of this machine is we also incorporate a grinding package so that we can actually grind the journals of this part. The grinding package consists of cycles, the dressing cycle, and also the dressing tool that will be mounted on the counter spindle. So that's a huge advantage when you want to process parts in one and still get the grinding done for higher accuracies and obviously good surface finishes. Okay, next slide, please. So this part demonstrates being able to process the part with 2 or even 3 turrets in the cut on the turning, and on the milling to be able to have 2 milling cutters simultaneously machining common features, and obviously for a huge reduction in cycle time. And one other thing to note here is that the part's supported by the counter spindle. So the manipulatability of a mill turn center is where one of its strengths over a conventional milling machine, where you can actually transfer the part into the counter spindle, support the part between 2 spindles, steady rest, centers. It offers a lot of opportunities to process parts efficiently. Thank you. Next slide, please. So this part is not a super complex part, but it's made out of a hard stainless steel. The primary thing here, or the primary concept, is that we do all of the turning on the main spindle with the turret and all of the milling on the counter spindle with the milling head. So again, reducing cycle time, whereas on a conventional turning machine and then a milling machine, the cycle time will be doubled on this part. Next slide, please. So this flange here, this is a fairly complex part done on G420. Our G420 comes equipped with 2 lower turrets, or it can be a steady rest. And in this case, the main spindle machining is processed using the B-axis and the lower turret, whilst at the same time the turret 3 is working on the counter spindle and finishing off the back working. Also, this part has got a ID spline that is process using a new process we have called power skiving, which is a tool that rotates in the milling spindle and in synchronization with the main spindle, and then thus producing a spline. That spline is basically machined almost like turning passes, like 3 or 4 passes, and is way quicker than the conventional way of shaping or broaching splines. Okay, next slide, please. And the last part here, this is kind of demonstrating the versatility of being able to rotate the head and still engage the grinding wheel on these journals. The part's supported between 2 pullback chucks with a face driver, and probably some hard turning operations here, and then some grinding operations. And you can see there with the way the head's laid over, the versatility of being able to access difficult to reach areas with the grinding wheel. Obviously, so again, reducing cycle time because the part's one and done. Okay, next slide, please. And it's over to you, Ed. Thank you.
What you're going to see here is just bear with me a second, folks. There we go. Index Corporation, we have a variety of turn mill machines in our R series and our G series. They're very similar in some respects, but they're quite different than other ones. The machine concepts of our turn mill products, all of them have 5-axis machining possible. They all have the motorized milling spindles, which allow for 5-axis simultaneous or 3+2 or 4+1 machining. We have 2 powerful, identical motorized work spindles, the main spindle and the counter spindle. We call it a counter spindle because it's an identical spindle to the main. There's nothing different between the 2. Again, robust motorized milling spindles. Our milling spindle is a motorized milling spindle. It's not gear driven. It is not a trunnion style. On our G series machines, we have lower turrets with Y-axis. On the 220, we have a single lower turret. On 420, we have 2 lower turrets. All stations are live tool capable. And again, Y-axis on. The tool change aspects on our machines. This is very critical too. We have a chip-to-chip time as quick as 6 seconds on our chip-to-chip time for tool change from the tool changer. We have very rapid traverse speeds and acceleration and decelerations of the main and counter spindles in the motorized milling spindle. This is actually extremely important for reducing on cycle time. And we use Siemens 840D solution line controls, but we have developed our own front end we call our IX panel operating system. This is Industry 4.0 ready, and I'll get into that here in a little bit more detail. The G series, the G220 and the G420, different size machines constructed very similarly. Basically, we have a center base that everything gets mounted to. Motorized milling spindle up at the top, riding on a hydrostatic bearing for the B-axis and Y-axis. lower turrets with Y-axis also. There's different configurations that you can utilize on these too. We can add steady rests. On the 220, we can go with a center tailstock rather than a counter spindle. But all machines do come with a part removal system. So a finished parts removal system. Our R-Series machines are configured a little bit differently because these do not have lower turrets. They have two 5-axis capable motorized milling spindles, each one working on its own work spindle. Main and counter, but they can pass parts between the two. This is not a shaft machine. We cannot machine shafts, but we can bar feed the machine. Turning capabilities. The work spindles are liquid cooled. This is to maintain accuracy and tolerance on the spindle. By being liquid cooled, we can hold the temperature constant. We won't deal with any thermal deformation whatsoever. The bearings are backlash-free bearing system, and the design of these spindles is symmetrical. So therefore, thermal deformation, if there is any thermal growth, it's going to be symmetrical throughout the entire spindle itself. Now, how we deal with this too is because we manufacture our own spindles. We machine the components, we assemble, and we do all testing before they go and get put into a machine. So we maintain very rigid protocol with regards to what goes into the machine, and it has to pass all the protocols. Milling capabilities. The motorized milling spindle is set up for potential of simultaneous 5-axis machining. It is a liquid-cooled spindle also. I'll get into this a little bit later of how we do this. The tools are loaded from the tool magazine. In the G series, it's a single double change arm. In the R series, there's a double change arm for each one of the motorized milling spindles. So they can load from the same tool changer or tool magazine to the spindles. Also, on some of the motorized milling spindles, we have the ability to go ahead and put 6 static tools mounted with the W serration on it for cutoff tools, common tools that you use quite often. You know, some of the advantages of the milling spindle is really about productivity, being able to machine all features, milling, turning, in the single machine. Got a short video I'm going to show you here too. With some power skiving. In the G series machines on our turrets, we have a unique tool system. It's a patented tooling system. It's called our W serration. In production, and production is in the eye of the beholder, it could be 10 pieces or it could be 10,000 pieces. What we do is a very fast tool change system. These are VDI tool holder mounting. People cringe at VDI tool holders because they're very inaccurate. So what we have done here is, since we machine our own turrets, we machine and grind a concave W on both the front and the back side of the outer circumference of the turret, as you can see on the right-hand side photograph. The tool holders then that we build, and we do license with some other makers of tool holders, the VDI holder that has the convex W serration ground into it. So what this gives you is very accurate repeatability of taking a tool holder out and putting a tool holder in. As a matter of fact, it's going to repeat within microns. But this gives you the speed of the VDI to be able to change a tool holder very quickly, yet it gives you the accuracy with the W serration where what you measure on a tool presetter can easily be loaded into the machine and you're off and running. High capacity tool magazines. On both the R's and the G series machines, we have very high tool capacity. We range from 50 tools in the tool magazine all the way up to 140 tools in the tool magazine. This really is the key for the index machines is the large volume in the magazine itself. This equates into reduction of setup costs, also with a quick tool change time, shorter idle times. It all equates to productivity and higher profits. The cooling system. All of our machines, including the turn mills, we use a cooling system for the spindles, some main counter spindle, motorized milling spindle, and actually the electric cabinet. These are all heat generating systems, and everybody knows heat is detrimental to maintaining tolerances. So we use a closed loop system for cooling, again, the main spindle, the counter spindle, the motorized milling spindle, and the electric cabinet, so we can maintain these tolerances. And the main advantage of this is efficiency, not having to chase parts because of thermal deformation on the different spindles and heat generated into the castings in the base of the machine through the electric cabinet. So that's really the main aspect of your advantage of doing this, is because of being able to be far more efficient machining your parts. The control, as I stated before, this is a Siemens 840D solution line control. The front end is the Index IX panel. The IX panel is very versatile. Things you can do with this is you can upload part drawings, setup sheets, tooling lists, routing lists. You can upload basically just about any document you'd like into the control and view it on the screen. This can eliminate having your plastic sleeves with your drawings and setup sheets following the parts. They can actually be uploaded into the machine along with the program. Other things that are on this too is manuals. Not only do you get hard copy manuals, but you also have the electronic copies of manuals all in the control that you can pull up parts lists, programming manuals, excuse me, troubleshooting lists, all right on the control panel screen. So you're not going to have to walk around and try and hunt down the manuals for when you're dealing with it. All the controls that we use an 18.5-inch color touchscreen control. Very easy on the eyes. In our system also, in our software, we've developed many L cycles, simplifying programming such as complex 5-axis tool paths. We can also add a secondary display screen that would slide out so you can have your drawings and setup sheets visible along with your main control screen. You know, basically the advantages of what we've got is we're giving you great accessibility to machine data. We can monitor things in the control. We can upload, download information, just to make it a much more simplified, user-friendly control. Excuse me. Index turn mills. You know, what are the advantages of the index turn mills over others? First of all, very powerful spindle motors. Our motors, again, we manufacture them in-house. They're designed for great tolerance, fantastic concentricities, but we also have very short acceleration times and deceleration times. This all equates into shorter cycle times. In the design of them, we've actually designed the spindles to be of lower rotating masses, which allow us to get into these much quicker acceleration and deceleration times. We manufacture the milling spindles, the motorized milling spindles also, very high horsepower, high torque milling spindles, typically much greater than anybody else out there. Allows you to go ahead and machine difficult materials and also very difficult geometries and remove a lot of material. On the G series machines, we have the multiple high capacity turrets. We have turrets with up to 18 tool stations. Again, all of them live, and all of our turrets are with Y-axis. The design of the bases of the machines are designed for torsional rigidity, so you don't get that twisting aspect out of it like you can in many other types of machines. Again, concentricities in our spindles and the dynamics, since we machine all critical components for our machines at Index, we're able to maintain these concentricities and tolerances in the machines. Again, we have high tool capacities, ranging between 50 and 140 tools on the machines. Gives you great opportunity to have redundant tooling and to store tooling for repeat jobs where your setup is going to be minimized, reducing piece part costs and increasing profitability. And lastly here, we can configure the machines to meet your needs. You don't have to purchase the machine in the configuration that it comes in. We can configure the machine into what meets your needs the best. I've got here one last video that I'm going to show you. This is of the G420. This is going to run here and show you a lot of the features of what is done with the 420. Index Corporation has been built over the last three years based on service and support. Approximately 80% of all employees at Index Corporation are customer support or applications. This is very critical for you, the end user, to know that you are backed by an organization that is focused on supporting them. We've had some difficult times here in the last 4, 5, 6 months, and Index has not reduced our workforce during this time because supporting our customers is extremely important, and it takes the talented people that we do bring on board. We can't lose them because they're very important to us. Also, we have a distributor network that we've built over the last 3 years that is very service-oriented and support-oriented also, something that was not the case with Index for a good number of years. So we've really built ourselves in the last number of years here as a very strong service support applications organization, not only internally, but through our distributor network. Index is here to help you. Our goal at Index is to provide you with the machines and solutions to make you more profitable. That's really the bottom line. We're here to help you. We can look at current processes and current applications and help you optimize them and how to optimize them to get the most profit out of machining them. We actually will do time studies, cost studies, develop turnkey solutions to meet your specific criteria, and actually the vast majority of every machine that we sell, we do acceptance runoffs on our floor before it ships. Again, making you comfortable with what we're dealing with and what we're doing. We're also here to help preventative maintenance. Why wait till things break down? We offer preventative maintenance on all Index machines. This allows you to make sure that things are going to be running when you need it to be running. And something that's very, very important to us is training. Training, you can only operate your machines as well as you've been trained. So not only operator training, but program training, maintenance training. These are things we can do remotely or we can do it in person, whichever way you would like to do it. But operator training is a very essential aspect of what we focus on in order to help our customers. So Index Corporation, we're here to help any way we can to help you be more profitable. We're down to the questions. Any questions?
Okay, so we do have a couple questions that have come in so far. Anyone that has a question who has not submitted it yet, please just look at your GoToWebinar control panel, and there should be a box there for questions where you can type in anything, and we will pass it on to Ed and Mark. First up, we had a question on the Siemens control asking what advantages does use of the Siemens control offer?
Hey, Mark, why don't you jump on that one, Mark?
Yeah, this is Mark Page here. So, having extensive experience as an application engineer, I've obviously worked with different control types such as FANUC and obviously Siemens. The main advantage of Siemens, or there's some actually quite big advantages, is it has a lot more functionality as regarding mill turn. Basically, there's some functions for milling on the face, tray seal as they call it, or transmit, sorry. Milling functions for milling on cylinders called tray seal. Makes milling very easy. You program it in a flat plane and then you wrap it around, the actual function wraps it around the part. The 5-axis functionality and the look ahead functions that enable the machine to run smoothly when it's doing mold milling or 5-axis milling are very powerful. Basically, and also if you decide that you want to do macro programming or you want to do some sort of external communication with robots or automation, again, the Siemens platform is very powerful. And the main reason for that is it's a completely open control, which means that you can access all of the system variables, and you can make some fairly sophisticated macros to make life easy for multiple parts that are very similar. Okay.
Thank you, Mark. The next question we have, what additional training would an operator need to work on one of these machines?
Do you want me to take that? So,
sure.
Basically, the operator for this kind of machine is going to be the best kind of operator is obviously someone who's had experience of turning and milling. The additional training that we would typically give would be primarily on the milling functions of the machine and the tool changer, how to load tools safely, how to organize the tools, how to manipulate the tools. There's on a mill turn machine, you can have special tools that have multiple positions, so how to control that kind of tool. We call them multi-tools. And also how to rescue the tool changer. It's a big factor, that tool changers do hang up. They do sometimes get contaminated with chips and they need to be rescued. So we also train the operator on how to rescue the tool changer safely.
Okay. Next we have, are the turret tools on these machines driven individually?
That's for you, Ed. I believe it's central motor, but
On these machines, yes, they are centrally driven. So no, they are not driven individually.
Okay, and then next, how often do you see companies pair turn mills with automation for lights out production?
very often, I would say.
Yeah.
You want me to answer
Go ahead,
that?
Mark.
Yeah, very often. Basically, the last two projects I've been working on, they've been complete automation projects. Again, the Siemens control and the mill turn machine, they make good candidates for automation. If you're doing a part one and done, it's nice to then be able to automate the rest of it, as in, taking it out of the machine with a robot, putting it on a CMM, measuring the part offline, but also being able to feed that information back to the machine control so that it can adjust offsets and keep the workflow running smoothly.
Okay, next.
Just to add to that,
go ahead.
I just wanted to add to that very quickly. Automation is becoming more and more popular in today's available employment of people. We are quoting more automation, and we are actually incorporating other people's automation on the floors too. They're incorporating it into the machine. So it's not just from us, it's coming from other sources too, and automation companies that are putting together large packages, such as Mark was saying, with CMMs, with clean-off stations, with stacking stations, things of that nature. So it's becoming more and more common than it used to be.
Okay. Next we have, do these machines require a special concrete pad?
No.
Just
a quick answer, no, unless you're sitting on 4 inches of unreinforced concrete on a sand bed. No, they do not require a specific foundation. Actually, G420, Mark, you might be able to answer that one. I'm not sure, but typically not.
Typically, with that type style of machine, you'd need around about a foot of concrete, reinforced concrete. For the 420, I mean, that's a 50,000 kilogram machine. So I would say in that case, especially being a concrete bed as well, that you would need at least 12 foot of concrete on that machine.
Okay. And then what types of parts could not be fully machined in a single setup on a turn mill?
I'll take that one. Basically, there's not actually many parts. The one limiting factor of a turn mill is against a conventional 5-axis milling machine is typically Y-axis travel and X-axis travel. So, you can buy basically a bigger 5-axis milling machine can typically cover a lot more ground or a lot more part. So sometimes you can get a part going on a mill turn machine that you can't reach a feature with the Y-axis, or the part's too big in diameter to be able to rotate the head at 90 degrees and machine features on the diameter. So typically that will be the limiting factor, is size. Now, that being said, if the part's not too big in diameter, but it's longer than the machine, you can actually feed the machine through the counter spindle and pull it and do multiple operations. And basically, it's like a conveyor belt where the part is being pulled and pulled and pulled and basically processed and pulled through the counter spindle. So I've actually machined parts that have been longer than the machine envelope using that style of process. Okay.
Okay, very good. It looks like that was the last of the questions we've received. If anyone does have any follow-up questions, feel free to reach out to us after the webinar and we will get back to you on those. I guess as we close things up, I just want to say thank you again to everyone who joined today for taking the time out of your schedule. We'll be getting a copy of a recording of this webinar out likely early next week, so keep an eye out for that in case you want to revisit any of it or share it with colleagues. And have a great rest of your Tuesday.